I'm going to go with teal. It's my favorite. I love blue. Blue colors. So here's, if you noticed, each problem sort of just levels up a little bit from the one before. Like, for example, on number 1, it's just a monomial times a monomial, right? One term times one term. And then on number 2, it's a monomial times a bunch of things in a group. That's distributive property, right? 3 is 2 things in a group times 2 things in another group. And then 4 is 2 things in a group times 3 things in a group. But the basic idea behind all of them still stays the same. So like, for example, on number 1, when I'm multiplying those 2 things, I'm multiplying the coefficients together. What's negative 6 times negative 9? Okay, 54. And then b to the 4th times b to the 5th. Am I adding the exponents or what? Yeah, I'm adding them, right? So it's b to the 9th. So who got that? Okay, that's the basic skill we're doing through all the rest of the problems, pretty much. So then for example, on number 2, we have this monomial times everything in this group. What's the name of that property? Distributive, right? Distributive. So I just do those one at a time. So I do 5x cubed times 2x to the 4th, which is 10x to the 7. Okay? And then 5x cubed times the next term, so that's 5 times the negative 2, negative 10. And then x cubed times another x cubed, x to the 6th, right? But now this last one's a little bit weird because it's 5x cubed times negative 3, but the negative 3 doesn't have any x's. So how am I going to handle that? X to the 0, right? That's really what's going on. It's x to the 0. So I do 5 times the negative 3, which is negative 15. It went away, yeah. I was like I was about to sneeze, sorry. And then x cubed times x to the 0, you're going to add the exponent, so it's still just x cubed, all right?
I just forgot. I added the x.
Oh, so you just had x. All right, so it's x. Now on number 3 and 4, here's the thing. Yesterday on your lesson, we went over FOIL, right? I kind of don't like FOIL. I went over it because it was in the book I was using, and I know we do it in other classes. And the reason why I don't like it is a couple things. One, sometimes people forget what the letters mean. I mean, they remember first, outside, inside, last, but they don't remember, well, which one's on the outside and which one's the inside or whatever. The other reason I don't like it is it only works for 2 things times 2 things. Like, you can't do FOIL on this problem, right? So here's how I like to think about it instead, and you might find this better. It's really just distributive property twice. Because here I've got x plus 8. I'm just going to take this 8 and distribute it through and get x squared plus 9x. And then I'm just going to take the 8 and distribute it through and get 8x plus 72. It will give me the same answer, and I don't have to remember what FOIL even means. It's just distributive property twice. And then we're going to use that exact same skill in number 4 in just a second. So then, but I have to finish out number 3, combining like terms. What combines here? The x's, right? So that's 17x. So I've got x squared plus 17x plus 72. Who got that one right? Yeah, that one's not so bad. And then on number 4, we're just going to do distributive property twice. Okay? So I have this y that I'm going to distribute through. Okay, so that gives me, what does y times y squared give me? And then y times negative 5y. And then y times that 2y. So I distributed the y. Now I have to distribute the what? Yeah, what kind of 3 is it? Negative. So I've got negative 3 times y squared, negative 3y squared. But watch, now that when the problems get a little bit bigger or longer like this, I like to start lining stuff up. Like negative 3y squared will go here with that right below the negative 5y squared. And then negative 3 times negative 5, positive. Positive 15y. And then negative 3 times that 2, is negative 6. And now I'm just going to add all of this up and down. I have y cubed minus 8y squared plus 17y minus 6. All right. Do any of you do box method? No. Box method works well for these problems too. It just is another way of keeping everything sort of in order. All right, so that was a quick review of what we did yesterday. Today, so what we did yesterday was multiply polynomials. On Tuesday, we added and subtracted. Yesterday, we multiplied. You know what we're doing today? We're dividing. We're spending 2 days on dividing. We're doing some kinds of division today and some other kinds of division tomorrow. So real quickly, though, I want to do a quick, can I say quick any more times? Here's how division looks for polynomials. We're going to start out with this section, dividing a monomial by nomial. It's just one term divided by one term. After that, we're going to do a polynomial divided by one term, a monomial. And that's all we're doing today. Tomorrow, we're going to talk about if we had a polynomial divided by not just one term, but by two terms, like this. And if you remember from Algebra 2, you might have repressed it. That's long division. Long division of polynomials. That's what we're doing tomorrow. I actually really like that. Once you get the hang of it, you're good to go. It's one of those things, though, that when you write it out on a piece of paper and go show your parents, it makes you look really smart. Because it's really long and has all this math. Okay, but today we're just starting out slowly with the division. One thing I do want to review in this box up here is the rules for when you're dividing and there's exponents, okay? So yesterday when we multiplied, what did we do with the exponents? Add. So what do you think we're doing when we divide? Subtracting, okay? So for this first example up here, x to the 7 over x to the 5, it's x to the 7 minus 5, which is x squared. But up here in this box, I just kind of wanted to show you real quickly why we have that rule. How does it work, technically? And we went over this last semester, so I'm not going to spend a long time on this. But x to the 7th really means 7 x's. Kind of like Scott Pilgrim, but they're not evil. And then, yeah. I like it. It's one of my favorites.
You should be sorry.
Yeah. Scott Pilgrim saves the world. I never would have watched it myself, but it was on repeat on cable. And so we kept catching it, and then we'd be like, oh, that was funny. Oh, yeah, that was funny. And now it's one of my favorite movies. Because I'm kind of old for it, but I like it a lot. Moving on. Scott Pilgrim saves the world. Or versus the world. Is it versus? Okay, so like Noah said, we're going to cancel out, right? That's what you said. Oh, you said that? Cancel, 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 cancel. And I'm left with x squared, right? One thing I want to remind you of, we always do that. We're like, cancel, 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 cancel. They're all gone. But what's really there in its place? When you're canceling stuff, it's really simplifying to what? Remember? 1, right? It's really x divided by x is 1. That one's 1. That one's 1. That one's 1. That one's 1. And those are all being multiplied. 1 times 1 times 1 times 1 times 1 is all just 1. But keep in mind that when everything cancels, you're really left over with a 1 there. So it's really x squared over 1, which is just x squared. So keep that in mind as I talk about this next one. Why do you think I have these two things that look awfully the same, but there's really something different? That's exactly right.
That is wonderful.
On the second one, on the first one, there's more x's on top, and on the second one, there's more x's on bottom. So let's talk about what happens there. We're still going to cancel out these x's. But now, what's left over on top? 1, right? 1, and then there's x squared on the bottom. And if you remember, we had a rule last semester. If we were subtracting the 3 minus 5, that would give me negative 2. But we had that rule about flipping it and making the exponent positive, and this is why we do that, why we have that rule. And then if I was simplifying something basic like 6 over 9, I would divide by the biggest factor that goes into both of them, which would be what? What goes into 6 and 9? 3. Right, it'd be 2/3. All right, so we're going to combine all these skills on this next section, where it says simplify the following. So these are just fractions with polynomials, not polynomials, algebraic expressions in them. One thing I want to show you, and you do not have to set up the problem like this, but it might be helpful as a visual, is there's two things going on in number 1. I'm simplifying the integer fraction, the one that's just numbers in the top and bottom, and the b part. Is that b cubed over b squared? It's hard for me to see on the smartboard. Okay, because it's so small. So you want to take it in little pieces, the number piece and the b piece. What is 27 divided by 9? 3. Now, b cubed over b squared is just b, right? And one thing we did when we went over these fraction rules last semester, we went over the y of everything like I just did, but then we switched over to this shortcut that I'm going to start right now. Where are the most b's, top or bottom? Top. So your base is going to stay in the top, and then you do the 3 minus 2 is 1, okay? So b is going to stay in the top because there were more b's on top. But on number 2, where are there more a's? Bottom. So our a is going to stay on the bottom. So for number 2, I still have two things. I have the number part, 18 over 12, and I have the a part, a squared over a cubed. What is the biggest number that I can divide out of 18? 6, right? Now, I could have done 2. Like maybe you didn't notice 6, but you knew 2 goes in. That would give you 9 over 6. You would just have to divide out by a number one more time. You'd have to divide out by 3. Yeah, you have to simplify more, exactly. But 6 will do it all at one time for you. So dividing by 6 gives me 3 over 2. And there's more a's on the bottom. So my a stays on the bottom. But there were 3, and I canceled out 2, so that leaves me 1a on the bottom. Yep. And if you want to see the a's out long just one more time, remember that means 2 a's on top, 3 a's on bottom. Cancel, cancel, leaves you 1a on bottom. You try number 3. Okay, how many different groups of things are here? 3 groups of things. It's the numbers, the 54 over negative 6, the a's, and the b's. So just doing those one at a time. 54 divided by negative 6 is what? Negative 9, right? You can do the negative on top or bottom or on the outside, as long as it's only in one spot. A squared over a, where are the most a's? On top. So a is going to stay on top, and how many are left over? Just the 1. B's, where are the most b's? So b stays on the bottom, and how many are left over? 3. 3, right? Is that it? Wait, is that it? Oh, it's a 3 on top? Okay. It's hard for me to see. Yeah, when you all had the same number, I was like, I know, I must have done something. So that's a 3 right there? I wrote it. Okay, so 2 left over. Very good. That's the answer. So what we're going to do for the next example, so here's how it's changing. 1, 2, and 3 was just one term divided by one term. For this next example, it's 3 terms divided by one term. And I have a video for that. Okay, so give me a second to put that up. What you're going to do is write down the steps and the work on the video. I'm going to pause it at opportune moments, and we're all going to just sort of work through it together. And the lady has a really cute accent, too.
To be more clear, concise, and powerful.
Okay, here we go.
Dividing a polynomial by an integer or an expression is really just another way of simplifying. There isn't actually anything new to learn. You just need to be able to simplify numbers and know how to divide with indices.
You know how to do that.
So let's jump straight in with an example, starting with dividing a polynomial by a number or integer. There are 3 simple steps to follow. Firstly, rewrite the question as a fraction.
All right, so rewrite the question as a fraction. All right, so this was our original problem, and you want to rewrite it like that. Okay, right. There's room on your worksheet to write the step. 1, rewrite the question. I wanted to see those, write those words down, and then rewrite it there as a fraction. Kind of, yes, at least even just in your head. Because what's going on here, and the reason why we're rewriting it is what we're about to do is basically distributive property for division. Each of those things in the numerator is going to get divided by 2. 8a divided by 2, 10b divided by 2, and negative 14 divided by 2. Okay, and that's going to be the next step is she's going to break it up into pieces.
Fractions, and then split the problem into pieces.
Okay, so then split it into pieces. You take each term in the numerator and write it over 2, because that's what you're dividing by. And these are actually really easy, because just dividing by 2, you're really only doing the number parts. 8 divided by 2, 10 divided by 2, and 14 divided by 2. The a's and b's don't get changed at all because there's no other variables to simplify them with.
By writing each term over the denominator, and finish by simplifying each term. Dividing a polynomial
Oh, come on, lady, you're
by an
too fast.
integer. Dividing a polynomial by an integer or an expression is really just another way of simplifying. There isn't actually anything new to learn. You just need to be able to
I don't want to mess
simplify
with it again because I'm
numbers
afraid of going too far forward.
and know how to divide with indices. So let's jump straight in with an example,
goes really
starting
fast, though.
with dividing a polynomial by a number or integer. There are 3 simple steps to follow. Firstly, rewrite the question as a fraction, and then split the problem into pieces by writing each term over the denominator, and finish by simplifying each term.
Okay, there's the answer. Okay, 4a plus 5b minus 7. That you do the 8 divided by 2 is 4, 10 divided by 2 is 5, 14 divided by 2 is 7. So the last step was simplify.
So 8a divided by 2 is 4a, 10b divided by 2 is 5b, and 14 divided by 2 is 7. Simple. We follow the same 3 simple steps.
Okay, so for this next problem, go ahead and rewrite the question. How are you rewriting it? You're rewriting it as a fraction, right? And then you're going to split it up into separate terms.
Dividing by monomials too. Rewrite it as a fraction, then split it up.
Okay, so take a minute and get that split up part done. That's really I think if you wanted to just understand the first step in your brain and skip straight to writing the second step, that's the most important step, is the splitting it up part, because it really breaks everything down into much more manageable chunks so that you can see what's going on with each different term. And I want you to go ahead and try and simplify. So after you get all of this from step 2 written down, you go ahead and try and simplify 6x to the 4th over 2x squared and all the rest of them, and see what you come up with.
And finish by simplifying.
How'd you do on those last 2? Who got the first 2 right? 3x squared minus 4x. Okay. Who got the last 2 wrong? Okay, let's talk about it. Let's talk about what's happening there. Okay. So 12 divided by 2 is 6. Did everybody get 6? But did you write 6x for your answer? Okay, because where are the most x's? On the bottom. So x is going to stay on the bottom. Okay, and then here for 4 over 2x squared. And you can even kind of do the same thing for the numbers, because what happens here when we're trying to figure out top or bottom, some people will say 4 divided by 2 is 2. They notice that the x stays on the bottom, so they put the 2 on the bottom as well. But 4 is bigger, so when you simplify, that 2 goes on top. 4 divided by 2 is 2. That's the blue part, and then x squared on the bottom. So we have 2 more example problems to do that you're just going to do on your own. The first one is like the first example. The second one is like this one, almost just like it. So pay attention to those last 2 terms when you do those last 2 examples on your notes, okay? And that's all we have to do today. We do not have a separate practice worksheet, just those last 2 examples on your homework, or your worksheet.
So 6
So
divided
go ahead and
by
start
2 to
those
get 3.
last 2 things.
X to the 4 divided by x squared becomes x squared. 8 divided by 2 to get 4. X to the 3 divided by x squared becomes x. 12 divided by 2 to get 6. An x on top divided by x squared leaves an x on the bottom. And 4 divided by 2 to get 2 on top, and the x squared stays on the bottom. So just take it step by step, and you'll have no problems. Give these questions a go. Pause the video, work them out. Dividing a polynomial by...
Oh, you're kidding. I did the exact same thing.
Polynomial by... Video, work them out, and click play with...
So how did y'all do? The only ones I think you might have messed up on are these 2, the 1 over 10 and the 2 over x squared. Forgot the 1 for the over 10. Pretty sure if you messed up anywhere else, it was just a silly mistake. Okay, so I'm going to leave this up here in case you were still finishing. Other than that, we are done for the day.